Okay, watch this. Watch this. Oh my gosh. Okay, here we go. We're going to drag in a parameter that's going to be count initially infected. Okay? What sort of parameter will that be? What's its type? An integer. Initially infected. Okay? I'll tell Jeff this, that the bear pit never saw so much beauty. Okay? AnyLogic didn't have this feature back then. Okay, and its default value will be 1. We'll just start with one person infected, okay? Okay, now, what we're going to do here is we're going to go and we are going to go to the population, and we are going to get a number of people that are distinct. So n distinct people as given by that parameter. Okay, and for each of those people, we're going to engage in infection behavior for them. Okay, and I actually don't have reference to the code here, but I know how to do it roughly, and Winchell is here, and so together we can do just about anything. Okay, so here's a count initially infective, and here's the initial infection event. So what we're basically going to do is we're going to go to the population. We can't just find one random person and expose them. And we can't just do that n times, because we might be selecting the same person again and again. So what we're going to do here is we're going to do stream, I believe, and then I think we want to do distinct. Distinct. Yes, we want to have a distinct stream, and then we want to do. We want to take that many people. What's take the Winchell for streams in Java? We have to do like find first. No, we want to get the first n. In Scala, it's take. What is it here? What is it? Limit. Thank you. I told you we could do amazing things. Okay, we want to do limit, and then we want to do count initially infective. Count initially infected. So this is going to get this many distinct people from the population. And then we're going to do for each. And then we're going to do, for that person, we will have them receive a message that says exposed. Okay? That, I believe, is... Yeah, I'm going to put it up on the big screen, because how could the beauty not be shown? So, is there a I put a semicolon inside instead of outside. Okay. Okay. Now we're happy. Okay. And here we go.
You put it 2 lines. Drop down the for each.
You want to mar its beauty by putting it on 2 lines? Okay, sure.
It's not hard.
Okay, okay, tell you what. So, well, here, this is the place to do it on 2 lines. You do it like this. Yeah. Okay. That's not too bad. Okay. So this population. We get the population. We turn into this thing called a stream that lets us do the powerful things that are coming up. We turn it into a distinct stream, a stream where we never get repeat elements. We take the first count initially infected numbers of them. So if we want 3 distinct ones, we take, or 3 to get infected, we take the first 3 distinct elements from this population. and then we do this. But wait a minute, we have to shuffle them. Yeah, and so how do you shuffle the stream?
Logic has a function called shuffle, but it's a in place shuffle.
I know it is.
Yeah, so to shuffle a stream, I guess the simplest way is just you can try to create a list of it and then shuffle it.
No,
using that
you
stuff.
could have integers and.
Yeah, or there probably there's another case. It will be.
Okay, we'll leave it like this for now, and then we'll come back to that. Yeah, later. Okay, fine. Okay, so this is. Yeah. Okay, fine.
Marked by reality, is that what you're saying?
Well, Winchell and I need to have a little talk later. Yeah, I think this isn't exactly what we want, but it's fine. So we'll take the 3 first distinct elements from this, and we'll send them all messages as exposed. Okay, great. Okay, do you have that? Okay. I don't see anyone swooning yet, but to computer scientists, that's beauty. Like a little bit like mathematician, e to the I pi equals -1. Okay, the TAs don't seem to be fully convinced either, but that's okay. They have learning still to do. Okay, great. Okay, so here we go. We're going to have one person initially infective, and the infection should then spread from person to person, okay? So is anyone getting infected? I actually don't see, I see people becoming susceptible. I see that, but I don't actually see someone getting infected here. Okay. Yes?
I think it'll work. It's just your rates for becoming, your timeouts for going through the other states are still one. It's just going so fast.
I don't think so, because they stay infected permanently.
Oh,
I think you had a typo in that last code. I think you spelled initially wrong. I think.
It would alert me if I spelled it wrong.
Yeah.
So I don't think so. It is spelled wrong, but so is the name of the parameter. So it's just whatever the parameter is. Okay, good call, but it doesn't help. Okay, so the question is, why isn't someone getting infected here?
Maybe you can starting from tracing by at the same time you receive the message, you also print it out. Make sure that you get to know who is receiving this message.
Yeah.
So basically,
Okay.
you just
Okay.
print out that person before they receive the message.
Sure, we could do that to just see who it is that's getting it.
Yeah, at least we get a proof that someone is receiving.
Yeah, so we're going to prove that someone receives it. I like Winchell's idea. So the hypothesis here, maybe somehow they're not receiving it. So we'll do 4 each here.
Yeah, it's still for each, just to really, at the later part of the lambda expression, we turn that into a curly bracket, and at first the sentence is perhaps trace LMP, and then a semicolon, and then P receives.
Okay. Yeah.
Well, it will break the beauty, but after we prove that someone did receive a restore.
Okay, fine. So that's possible. Okay, that's another hypothesis. But yeah, that's another hypothesis. I'll just go to person, go to connections. Let's make sure that the connections object is communicating. It's not going to the infection state chart. Good man. Good man.
That was Tina.
That was Tina.
Yeah.
Good lady.
Yeah.
Awesome. Okay, so you go to the person, and you go to connections. You guys are great. And I didn't have you alone in the bear pit. And we go to connections, and when you go to connections in person, you sometimes have to make sure that it forwards it. And it seems to be, sometimes it does automatically, sometimes it doesn't, and you gotta just check. And
No, it always should be defaulted. So what that means, so I don't know if we really talked about this, but when you send a message, agents communicate to each other through messages, right? And so they have this, I think it's a bit fuzzy myself, but maybe there's a reason for it. Each state chart can receive a message independently. So what that connection object does, the little checkbox is, okay, which state charts am I going to
I know what it is.
messages to? So the
No.
connection object is kind of the receiving point within the person.
oh, this dumb thing.
And so if you're sending it to that person, then that then sends it off
That's
to
what
each
Alex
of the
said.
state charts. And there might be some reason you would want to, so that a state chart can receive messages, but I don't know why that would be the case. So for me, you always, it's both, they should be clicked by default, but sometimes because there's
Yeah.
bugs. they're
So,
not, so.
long story short, if you have, particularly if you have multiple state charts and one or more of them needs messages, go to connections and make sure that under this communications area, it forwards it to both.
I don't know why.
Tina's awesome.
Yeah, I don't know why you'd ever not want to have a message be able to be received, but whatever.
Yeah.
There is also, mine get infected, but the thing is that it takes 3 days because they get first exposed
Yeah.
and it takes 3 days to become infected, and then they become infected.
Right, and one thing that Alex pointed out, I thought actually that we had fixed this transition back to susceptible is still a timeout of 1 day, and so they may not spread it to anyone. So we want to turn this into a message transition. This will be if they're exposed to the healing beam. Okay? This is for the beam exposure in the short term. And later we'll change it to a laying of the hands of Jeff. Okay? Okay, so now if we change this to a message, we want to make this on a particular message, and we actually want it to, we'll come back to what this message is, okay? So they won't actually go down here right now. And if we run it, we will see them get exposed, get infective, and they will likely pass it on here. So you notice this person was infective, and now we're starting to see that person up. They've become transmissible, and now we have different people, and now we have an infection of crisis proportion spreading through the fair city, ladies and gentlemen, the fair city of Saskatoon. Okay, so in homes and workplaces, infection is spread, and it's spread from one initial seed person to others. Winchell, maybe you can investigate shuffling, see if there's a better way to do it these days. Yeah. You did? You already did?
Yeah.
Okay, can we do it in more than one line? Or can we do it in one line or no?
No, well, that'd be a long line, but it'd be one line.
Okay, I'll see you later. Okay. Good man. Okay, ladies and gentlemen, so let's just be clear about what happened. Let's be clear about how we added infection to this model, because I don't want to be confused about it. There was a lot of back and forth, and paeans to beauty and the aesthetics of code, and I don't want you to lose track. Basically, when we added infection transmission, there were 3 essential things that went wrong. It's actually not very hard to do. There's 3 essential things that happen. Number 1, we set an infection transmission that's contingent on a message being received. So I'm exposed, and it's indicated to me by a message. We made that automatically infect them. Later, not with this model, we'll see how you can have conditional cases. you have a certain probability of being exposed. Second of all, we have a transmission mechanism whereby if someone's infective, they can transmit to others. And particularly they send message to others over the network. Here, we had them sending some message, and whatever message they receive here, they're going to go on to become infective. So it didn't really matter exactly what message we had. Soon enough it will. Those are two of the three. The third thing we did is in Maine, we put in place a mechanism to infect in a certain number of initial infectives. And there was beauty and some truth in that. But fundamentally, we sent a person a message. We had them receive a message saying you're exposed. Those are the three things that go together. You need some sort of network. Here, because we're in GIS, there was some awkwardness about just saying make there be this network. For most any logic environments, non-GIS environments, you can just say make there be a distance-based network. And it's beautiful. But for whatever reason known to those in St. Petersburg, they disabled that for GIS automatically. And we had to do this thing where we connect to people in different environments. And so people can bring an infection from home to work, and then others can bring it from work to home, and it can spread throughout the network. So we had one person who initially got infected. That one person was infected at some point, whether at work or at home, brought them between those environments, and because they were co-located with others who worked or lived at the same place, they spread it to other people, and it just kept on spreading out from there. Workplaces got afflicted, brought them to many homes. The people at those homes lived in other workplaces. It spread onwards, and it spread outwards. And now we have people, ladies and gentlemen, who are infected throughout the population. And what do those people need to be cured? What do those people need to move beyond their affliction? Ladies and gentlemen, they need to seek care. They need to engage in care seeking. And wheretofore in the model will they go? They will go to the clinics. To which clinic will they repair? To the nearest clinic, ladies and gentlemen. To the nearest one. Okay, so person. The afflicted individual will repair to a clinic. In order to do this, and to do it well, we will best represent the clinic in the location state chart. We add in, therefore, a new state, and it's going to be called under care. Under care. You might call it in care, alternatively, if it communicates better to you. And there's going to be transitions from either home or from work to this state. This example brings back memories of Adelaide, because we went through a similar little issue there, and we found an ugly thing that required accommodation. Okay, ladies and gentlemen, from either at home or under care, a person may repair, or at work or at home, they may go back to an undercare state. But under what condition will they seek care? If they are what? Infective. That's right. If they're infective. So we need to make these conditions conditional under the presence of infection. I'm going to turn them into hazard rates. So they will associate a hazard rate with a rate of 0.2, so on average in 5 days, 1 over 0.2, they will seek care if they're infective. And similarly, from at home, we'll also use the same rate of 0.2. So those will be rate transitions, and then we'll put in a tiny bit of logic to capture the fact that they have to be infective. Now, wind chill, I'm curious. I lacked recourse to wind chill from the Bear Pit, and I lacked it also whilst in Adelaide. So I'm going to ask him if he can better how we did it from Adelaide. And Winchell can tell me if he has a better suggestion. So in order to limit these transitions to only take place when a person is infective, we put down a guard. But the guard has to be reevaluated with a self-transition. Otherwise, it doesn't get questioned. Okay? So a guard here, and the guard will basically say, under what condition is this transition valid? The transition is only valid if they are in the infection state chart. So actually, I can just say this dot in state infective or person dot infective and symptomatic. There we are. That's the guard, and that guard applies to both of these. I'll go put it up on the big screen, but it applies to both transitions. There we are. And there's one final bit of ugliness that's required. Is that right, Winchell? Yeah. Do you know of a better way to do it? Yeah. Okay. Okay. The Adelaide consensus is validated some years later. Okay. Joachim, Jeff McDonald, and I came to a consensus that wasn't a terrible thing. Okay, Dylan, I think, was also present. Okay, yes.
I'm just wondering why is it the person, not these?
Sorry, why is it?
The person there.
Oh, person? It's because it's infective and symptomatic state with respect to person. You actually don't need this right here because we're inside a person, but it's always good because when you refer to states outside a person, you have to be very clear. You're talking about this state inside a person. So to avoid confusing people in my boot camps, I tend to just automatically, when I refer to a state name, report where that state lives before it. This is the infective and symptomatic state for a person. And that's why we say person dot infective and symptomatic. It belongs to all of person. It's not different for each individual person. So it's a property of the person class as a whole. We say it's a static property, unfortunately, in Java. So this is a property of the person class, and infective and symptomatic is the name of the state. We might have an infective and symptomatic state for dogs, which is separate. Okay? And so we just make that distinction. You have to do this for statistics, for example. And so I typically just do it by force of habit. Well, no, by conscious consistency. Okay, ladies and gentlemen. So we have that, but there's one final thing that's needed here. Because infective and symptomatic might change over time, and a guard is only examined once for each entry. But then again, Winchell, you're entering into this frequently. So, we could do it every hour they examine it, but it's only every 5 days. So I think we'll leave it here. Yeah, okay. So only if they come to work while infectious and symptomatic do they consider going or at home. Okay, ladies and gentlemen. So here they repair to care. And now we will have them travel to the nearest clinic. Okay. So our guest speakers are here.
Before the guest speakers begin, I would suggest a nice break.
Okay?
We have muffins, we have donuts, we have water.
Okay, so I want to finish this thought. There's only one line of code we have to write. For now, to have them go to the clinic. The problem is they're going to end up in the clinic for a while, but that's okay, until the healing beam is provided. Okay? So, when they enter this under care state, they're going to do this dot move to, and they'll move to the main dot clinics. It's the nearest one. So I'm sorry, I just have to check this. It's the nearest get nearest agent. There it is. It's move to this dot get nearest agent of main dot clinics. I'll put this up on the big screen here so you can see it. But this is the key logic. They will move to the nearest of the clinics to themselves. And having found that nearest clinic, we will move to that location. We, meaning this agent, will move to that location. So we first find all clinics. We find the nearest one to ourselves, and we move ourselves to said location. That's what's going on there. Okay. So they will pursue at that clinic I'm not getting the right word. Kurt might know it. The salutary properties, the healing properties of the healing beam. But there's another word besides healing. It's the therapeutic properties of the healing beam. Okay? They'll move to the clinic. So what do you think will happen as we run this model now? Where do you think people will be? They'll all repair to the clinic in the fullness of time. Sorry? Well, I did move to, because they'll drive a line there. We could have done jump to just as easily. But watch this. They're getting infected, and some of them are seeking out the solace of the clinic. Do you see them? They're piling up at the clinic. Do you see that? Okay, they've repaired to the clinic. And after the guest lecture, we'll finish up the thought by having clinic workflow, by which it will subject them at first to a beam of healing energy, and then they'll be subject to a workflow, okay, which addresses them, but where they may balk and they may leave without being seen and continue to spread the infection. Okay, ladies and gentlemen, that's it for now, and I will confer with Winchell on things of beauty. Okay, thanks very much. Okay.